So here's a warm-up question that you should solve. So please pause the video right now and get this answer. Yes, I'm expecting you to do that. So pause the video, find the vertex of the parabola. There's a couple ways to do that. So you should have an answer by now. And so if you didn't, you need to pause this, go back and do that. But when you're thinking about the vertex of a parabola, you could, one option would be to complete the square. So really, maybe I want to take just a little step back here and notice that we have slightly switched because we were starting with a function before, just this, and then we're saying now taking it the step of the solving. And so maybe I should probably just go back to this moment because I'm talking about a parabola. This is actually just an equation that should just be two answers. So when we think about this parabola, and I'm going to find its vertex, the x value, we could get that by thinking of opposite b over 2a, which in this case would be positive 2, opposite 2, over 2 times 1. So that would reduce to 1. So that says the x value of the vertex is 1. If you want the y value, you could just plug that into the function. So minus 17 plus 1 minus 16. So we have a vertex then at 1 comma minus 16. We should also be able to know like which way this parabola is opening. And it's definitely opening up, right? Positive leading coefficient here. And so if we think about that point, 1 minus 16, and a parabola that is opening up, it's got to cross the x-axis somewhere. In fact, it has to cross twice. There's no other option for that. So if you go ahead and finish and solve that, now we are really into either a factoring or quadratic formula kind of question, because now I could say x minus 2x minus 15 equals 0. Easiest thing here to do is probably to factor this because it's x minus 5x plus 3, which again, this 0 is very important. If that's not 0, the logic here is saying blue times green is yellow. So either the blue thing is 0 or the green thing is 0 or both of them are 0. But one of them at least must be 0, and that's why we end up writing, why it moved that, writing one of these equal to 0 and solving, or each of them I should say. So this one here is x equals 5, so where it's going to end up crossing here is at the x value 5, the y value 0 because it's the x-axis, and then here the x value is minus 3, comma 0. Okay, so a lot of old news here. Like there shouldn't be anything that I did that you're like, oh, I don't understand that. If you did, you need to go back a section. Okay, but where we're going to go now is to flip this a little bit. Instead of moving away from the equation and thinking about the inequality. Okay, the inequality. Let me just copy this real quick. And so it's solving this inequality. So maybe before we solve this whole thing, let's go back to this statement. Okay. And if you notice that f of x is really all of that stuff in that inequality there. So when it's actually saying solve less than or equal to 0, I could rewrite it then and say I'm looking for f of x less than or equal to 0. So what I have here in Desmos is just that same function that we solved a minute ago. And first, it was the same function. So just trying to get both of these on the screen here. So here is our work just a second ago, finding this x-intercept at 5, 0, and we can see that here, finding this x-intercept here at negative 3, 0. So what we're switching though now to is saying f of x is less than or equal to 0. Now, for several years, like you have been told that if you're thinking about f of x, you should just think of y. So really, if I'm saying f of x is less than or equal to 0, that definitely did not graph that right. Let me draw this differently. Okay, so I just wanted to make this look maybe a little bit better. So maybe the first observation is when we typed this in, do you notice that what Desmos did was it's drawn a vertical line here at negative 3. Do you see that? I just have a point that if I move it up and down, that x value there is always minus 3. And then here, I have another vertical line that at x equals 5. And then all of this stuff between them is shaded. So really what it's saying here is that the solution, so let me hide this again for just a second. When I think about the solution of where this thing equals 0, I'm getting these two values. Okay, so continuing this with, so when we were solving the equation and we're getting these two values, notice that there's two answers. Then if I ask the computer here to graph f of x less than or equal to 0, again, it has graphed like this vertical line at x equals minus 3, and this vertical line at x equals 5. And it's shaded everything in between. So the first observation here is that the solution to this inequality is a bunch of x values. Do you notice that we're graphing everything between the x value here of negative 3 and then the x value of 5? If you look at this original red graph, do you notice that those are the moments where the y value is less than or equal to 0? So when you look at all of these y values here of this curve, they're all less than or equal to 0, any x value between these two x values. Okay, so that means, so if I'm going to take this, I'm going to put this back on my other screen here for us. And so when I'm thinking about the solution to this inequality, I would end up writing something like this. I could write an interval notation then, so I would say minus 3 comma 5 bracket. And so again, the answer to this, I might say it this way, it's the x's where the y's are less than or equal to 0. So our solution are x's where the y's are less than or equal to 0. Again, looking at the graph, do you notice that the y's are less than or equal to 0, there to there, right? That's below the x-axis. And then so the solution, though, are the x's where that's happening. It's basically like if I think about all the points on this curve where the y is less than or equal to 0. Well, what would their x's be? Well, any number between -3 and 5. Let's do another one. Solve the inequality here and graph the solution set. So again, I'm going to start with thinking about maybe even thinking about making an adjustment here first. Because looking at this, I could solve it the way it is, but it might be easier to make a comparison to 0. Otherwise, what we'd be saying is where f of x is greater than 1. And so when I think about whatever parabola I end up drawing, I'm going to have to now compare it to some line y equals 1. It just tends to be easier not to do that. So that inequality should be the same as that inequality. So we're going to think about f of x equals x squared minus 2x minus 15. We're going to think about the graph of this. So we could get things like, well, actually, if you look at it, is this any different than what we just did? It's not. So the inequality is different, but now the solutions to this and where the vertices are won't be. So effectively, we still have this same parabola. This is going to factor into x minus 5 and x plus 3. And so we have the same parabola here. We have a vertex at opposite b over 2a minus 2 over 2 times 1. It's minus 1. So we have the axis of symmetry here. We have an x-intercept over here at 5, 0. Again, you shouldn't need a calculator for any of this. I did something wrong there. The axis symmetry should be over at 1. Opposite b is plus 2, so it's at 1. I realized it was wrong, and this is how you can realize it's wrong, is that it has to be halfway between those 2 points. If it's not, it's definitely wrong. So when you look here, that distance is 4, and then that would be 3, and then 1 more. So it has to be evenly spaced there. And so we have our parabola comes down, vertex on that line comes back up. So same parabola. Difference, though, is that. So it is now saying, tell me the x's, and this is again why the solution is x's, right? Isn't this x's? So shouldn't we be saying x? Usually we think x equals. So here we're having some interval of x's. So I need the x's that make that true, which are going to correspond to, again, where the y values are bigger than 0. Okay, so I look at this graph and I'm going to have y values bigger than 0 there and there. So what x's cause that to happen? And again, you could just kind of think about the points if you wanted. So all these points on the curve here to here to here would be x's here and over. Now, we actually don't want that point right there at minus 3. Hopefully you see why. I want strictly bigger than 0 in this case, not equal to. So there's actually open circles there, and the arrows go this way. So if I was going to try to write these intervals, I would have minus infinity, comma minus 3. So that's all of this going this way on the number line, not including minus 3, remember parentheses. We could say union, so that or this 5 to infinity. Okay, and there is our second solution. So a couple takeaways here. Comparison to 0 is always easier. And again, we're looking for, like, once you graph or think about the graph of the parabola, we want the x's that make that the y's do a certain thing. We could have multiple parabolas here. And so, like, really the interpretation would be something like this. Like, if this says f of x is greater than g of x, and that's f of x, and that's g of x. It's really looking for where this parabola is above this parabola. So let me see if I can show that here to you. So here are the two graphs. So we have f of x, the red one, and then we have g of x, the purple one. And so it's asking for where the red one is bigger, right, above, bigger y values than the purple. And so sometimes students look at this and go nowhere, because you start looking at the y value here and think this one's always above. It's not true. If I pick an x value, like so when we think about like the x value here, so this is 1, 2, at 3. Do you notice that the red curve would have an answer of 0 at 3, but the purple one has a negative answer, right? So when we're making the comparison, we're making this vertical comparison here. And so when we think about this point and then compare it to like this point down here, yeah, the red curve is above, right? It is greater. 0 is greater than -7. And so that would be a solution to it. Do you notice that at this moment they seem to switch? And so it's harder to, again, it's harder to look at the graphs here because then it's like, well, what happens on this right side? Like, do they ever switch and how do I find that? So instead, we're going to make an adjustment here. So what we're going to do, I'm going to go ahead and try to write the statement that's given. So just going to go ahead and say negative x squared plus 2x plus 3 greater than negative x squared minus 2x plus 8. Well, it's an inequality, and just like an inequality, as long as I do certain things to it, I can keep it the same. I can keep the truth of it the same. The only difference, remember, about the inequality is like that multiplication division by a negative. And other than that, you just treat it the same. So do you notice here, I could actually get this to simplify. Maybe I'll add this 2x to this side, minus 3 from this side, and when I finish, I get this, 4x greater than 5. And so really, if I want the solution, so when I started with this statement, and I'm saying what are the x values that make that true? And if I look at this, do you notice that the solution says any x bigger than 5/4? So starting at 1.25 to infinity. And so if I go back here to Desmos, that's exactly actually what we saw. Do you notice right here, this point, not that one, that one, that they're sharing this point at 1.25. 1.25 is this moment where it's switching from which curve is above, right? Definitely over here, purple is above, but over here, we already talked about red is above. And so really what that says is after that moment, the red one will always be above. Now don't look left and right. Again, it's like you're following a vertical line down. Right, so if I look at this vertical line and I find the y value, I'm going to get to the y value of the red one first, and then if I continue to follow the line down, I get to the purple one next. So that's what I mean above and below. Okay. So another option here that you could think about is you could actually be graphing, I could rewrite this and say 4x minus 5 greater than 0. And you could have the same approach, we're doing right now with the parabola. Like I could be graphing that line and telling the x values that are greater than 0, And that's going to also give us these values at 1.25. So last example here, so we think about these questions. So why don't you try this one on your own? So pause the video, try it. So here's the graph, and so when you find that vertex here, it actually is also the x-intercept, and so the answer is 1/3 for that x-intercept. And so our question was, where is the graph less than 0? Well, I think Desmos really gives it away. Because if I have a parabola that's opening up, and if it's touching the x-axis there and doesn't go under it, well, never, right? There is no y value here for this graph that is below the x-axis. So what are the x's where the y value is below? None. There are none. And so we could just say that there's no solution to this. We could say the empty set, which is saying there are no numbers that would satisfy that. So it's also possible to have something where everything is the solution. Like if I would say greater than or equal to 0, well, and again, if the whole graph is on the x-axis or above, then the x's, where that's y, right? So where are the y's bigger than or equal to 0? Well, any x value. So again, remember that you're telling me x values as solutions here, and that's the key, okay? So that is the start here of 2.5. You do have my math lab as well for this section. Really key ideas going back to where we started. If you're trying to think about solving an equation or an inequality, it's really helpful to think about the function. So here's the function, there's the inequality. Why is that? Because then I can understand this graph, find its x-intercepts. It's always going to be connected to its x-intercepts. And notice that our solutions are either going to be often between the x-intercepts or this group that's outside the x-intercepts. And then we have the two exceptions of nothing or everything, okay? So keys to these questions, notice original problem here has nothing to do with y, nothing to do with f of x. It's all about x. So be sure your answers are telling me x values. Okay? So start the homework and then we can talk about questions you have in class.